Welcome, my friends! In this video, we will be discussing discrete probability distributions. Let's begin by introducing random variables. A quantitative variable x is a random variable if the value of x is the result of chance or some random process. Random variables can either be discrete or continuous. A discrete random variable can take on a finite number of values within a range, typically whole numbers found as the result of counting. For example, we might let x equal the number of free throws made out of 2 shots. Only a finite number of shots can be made, either 0, 1, or 2. Some values, such as 1.5 free throws made, make no sense and are not possible values for this discrete random variable. A continuous random variable can take on an infinite number of values within a range, including decimals. Continuous random variables are typically associated with measurement on a continuous scale. For example, we might let x equal the height of a random individual in Michigan. Height can be measured continuously, so values like 72.534 inches are possible, or really any value if we measure precisely enough, which is what makes height a continuous random variable. Both discrete and continuous random variables have probability distributions, which describe how likely all outcomes of the random variable are to occur. The focus on the rest of this video will be on discrete probability distributions. In order for a discrete probability distribution to be valid, it must satisfy 2 conditions. First, all probabilities must sum to 1. Second, all probabilities must be between 0 and 1. To find the mean of a discrete probability distribution, sometimes called the expected value, we use the formula mu is equal to the sum of x times p of x. The Greek uppercase letter sigma means sum. X represents the possible values of the random variable. P of x represents the corresponding probabilities of the random variable x. And the Greek letter lowercase mu is the population mean. So this formula is telling us to multiply each value x by the corresponding probability p of x, and then to add up all of the products. To find the standard deviation of a discrete probability distribution, we take the square root of the sum of x minus mu squared times p of x. The Greek letter lowercase sigma represents the population standard deviation, a measure of the spread of the distribution. Everything on this slide might seem a little fuzzy right now, but it will hopefully start to make more sense when we look at an example. Here's an example of a probability distribution for the discrete random variable x equals the number of free throws made out of 2 shots. Let's assume these probabilities are known for a particular basketball player based on historical data. There is a 20% chance that none of the free throws are made, a 50% chance that 1 is made, and a 30% chance that 2 are made. We call x a random variable because every time 2 free throws are shot, one of these outcomes will be the result, either 0, 1, or 2. Which result we observe is random. It's like generating a random number, which will either be 0, 1, or 2, except some of the values are weighted higher than the others, such as 1, which happens 50% of the time, and others are weighted less, like 0, which only happens 20% of the time. Okay, first question. Is this a valid probability distribution? We must check the 2 requirements we discussed earlier. Do all the probabilities sum to 1? Yes, they do. 0.2 plus 0.5 plus 0.3 equals 1. Are all the probabilities between 0 and 1? Yes, they are. All values in the p of x column are between 0 and 1. Since the 2 conditions are met, this is a valid probability distribution. Next, let's calculate the mean, which is equal to the sum of x times p of x. To calculate the mean, we simply take each value x and then multiply by the corresponding probability of x and add all the numbers together. The easiest way is just to add another column to the probability distribution and multiply across. 0 times 0.2 equals 0, 1 times 0.5 equals 0.5, and 2 times 0.3 equals 0.6. Adding these values together, we get the expected value, or mean, to be 1.1. On average, 1.1 free throw shots are made. Notice that the expected value of 1.1 is not a possible value for this probability distribution. That's perfectly fine. The mean doesn't need to be one of the possible values of the random variable. Next, let's calculate the standard deviation. The formula tells us to take the square root of the sum of x minus mu squared times the probability of x. Let's break this into steps. First, let's do the inside of the parentheses, x minus mu. So we make another column for x minus mu. We take each observation x and subtract mu, the mean of 1.1. So we have 0 minus 1.1, which is equal to negative 1.1, 1 minus 1.1, which is negative 0.1, and 2 minus 1.1, which is equal to 0.9. Then we add another column for x minus mu squared. All we need to do is to square the value from the previous column. Negative 1.1 squared is negative 1.1 times negative 1.1, which is equal to 1.21. Negative 0.1 squared is 0.01, and 0.9 squared is 0.81. Now we multiply each of these values by the corresponding values in the p of x column to complete everything underneath the square root in the formula. 1.21 times 0.2 equals 0.242. 0.01 times 0.5 equals 0.005. 0.81 times 0.3 equals 0.243. Then we are told to add all of these numbers up by the summation symbol. 0.242 plus 0.005 plus 0.243 equals 0.49. What we have is the sum of x minus mu squared times p of x, the entire formula without the square root. This turns out to be the variance, or sigma squared. We can find the standard deviation by taking the square root of the variance. The square root of 0.49 is 0.7. Now this process can get a little bit tedious, especially when there are more than 3 outcomes in your distribution. Let's look at how you can calculate the mean and standard deviation of a discrete probability distribution on a TI calculator. Okay, here we are with the TI-84 calculator. We need to enter the distribution into the stat list. First press Stat, and then press Enter to edit the lists. If you already have data in List 1 and List 2, scroll up so that L1 is highlighted, and then press Clear, and then press the down arrow. Do the same thing for List 2. Hover over List 2, press Clear, and then press the down arrow. Now type in your probability distribution. The values for x go into List 1, and the values for p of x go into List 2. So we have 0, 1, and 2 for List 1. Then we can arrow over to List 2 and enter 0.2, 0.5, and 0.3. Press Stat again and arrow to the right to get to the Calculate menu. Select the first option, One Variable Statistics. Make sure your lists say L1 and L2. If not, you can press second 1 to enter L1 or second L2 to enter L2 into the frequency list. If you have an older calculator or a TI-83, it will look like this, and you will have to type in L1, L2. Okay, arrow down to calculate and then press Enter. We see the mean, x bar, is 1.1 and the standard deviation is 0.7, just like we got earlier. Here is another discrete probability distribution where x equals the number of boats Johnny Smith sells in a day. This time we are missing one of the probabilities, the probability of selling 3 boats. To find the missing value, we use the idea that all of the probabilities must sum to 1. Adding up the other probabilities, we get 0.75. So we are 0.25 short of summing to 1. Meaning the missing probability for 3 boats sold is 0.25. We might ask additional probability questions about the distribution. For example, what is the probability Johnny Smith doesn't sell any boats in a day? This could be written as the probability that x is equal to 0. There is only one outcome where 0 boats are sold, and the probability is 0.05. There is a 5% chance that Johnny Smith fails to sell any boats in a day. How about the probability Johnny Smith sells at least 3 boats in a day? The phrase at least 3 translates into the probability x is greater than or equal to 3, and includes the outcomes of 3 or 4 boats being sold. To find the probability, we add up the two corresponding probabilities, 0.25 and 0.1, to get 0.35. Another question could be, what is the probability Johnny Smith sells less than 2 boats in a day? This could be written as the probability x is less than 2. Note that less than 2 does not include the outcome 2, so the only two outcomes that we are interested in are either 1 or 0 boats being sold. Adding up the probabilities, we get 0.05 plus 0.2, which is 0.25. Alright, my friends, we have finished our discussion of discrete probability distributions. We will be exploring many more fun and exciting statistical topics that you won't want to miss, so make sure to check out our other videos.